Welcome back to my channel, everyone. Sweet Tips here. What I have here is some gold filled scrap that I'm working on right now. These are the watch band caps that we pull off of these watch bands, and I have to sit here. It's probably take me 20 minutes just to pull the caps off of one of these watch bands. I got to sit here until I get that piece right there. And it takes quite a while to do all this. But before I commit this gold-filled scrap to the acids, what I'm going to do is I've got a little tea strainer here. You put tea in this and then put it in your cup. But it's very effective for putting these pieces of watch band material that are just filthy. And then we're going to put these over here into the ultrasonic cleaner and start that up. Next, I've got some gold filled scrap pieces here that I've cleaned mechanically. Took all the non-gold filled material out of this. I'm going to put it in this strainer here. What we'll do is we'll take this over now and stick this in the ultrasonic and allow this to cook in here as well. Pull this out of here now. That's our gold filled scrap. And this is really not necessary. One could get away with just incinerating this material, but I like to clean it up like this. The cleaner it is, the easier it is to process. Now that we've got all the soap rinsed off, I'll take it over here and we'll steam it off with the steamer. This will blow any dirt, debris off of there. Really cleans this material up nicely for us. And now what we'll do is set it down in here with the rest of our material. See how nice and clean that stuff is now? Like I said, it's not necessary to have to do this, but it sure does go a long way in removing dirt, grease, and grime, and makes the processing a little bit easier. Now let's get our watch band covers here. Rinse this off. And we'll steam this off now. And then this stuff we put right in here in this little container. And then we'll put some more in here and do another batch. But as you can see, the watch band pieces are nice and clean now also. People like to ask, what's the difference between gold filled and gold plated? And if you notice right here, it's a piece of base metal in the middle with a thick layer of karat gold on top and bottom in some cases. And then they heat it up and bond the karat gold up here to the base metal that's in the middle, and run it through some rollers, and then they use this material to make jewelry from. If you look at these pieces of gold filled scrap, here's one that says 1/20th 12K. I can't hardly see that. 1/20th 12K GF. Here's another piece. It means it's got a thick coating of gold over brass. Guaranteed to be 14K gold with plate composition between so forth. It says 25 years warranty here, so that means you can pull it in and out of your pocket for 25 years before the thick karat gold will wear away and reveal the brass base metal underneath. See if we can find it down there. There's a little circle right there by my thumb that says gold filled 12K GF. You'll see like here's one that says gold filled on the outside of the piece. Right there, gold filled. Has gold filled on it. 1/20th 12K gold filled. And let's see, these pens, they have it on there. Right up on the top. You can identify this as gold filled. It'll be marked right on the top, usually. Another simple test we can do is use some 14K gold testing acid here. And I've got a piece of known gold filled material clearly marked right here. If we put a drop of the acid right directly on the piece, you'll notice it will just sit there and not react. That's because this is karat gold over brass, and the karat gold will protect the brass underneath. However, if we've got a piece of gold plated material like I've got right here, we put some test acid on this directly on the piece, and you'll notice that we get an immediate, almost immediate reaction. It starts bubbling, turning green, and that's because there's only a few microns of gold plating on here. The acid will eat through it almost immediately and reveal the base metal underneath. Notice that our gold filled material is still resisting the acid. Here's a piece that I put on there about a minute ago or so, maybe two now. So this has got a thicker coating of gold plating on it. It hasn't eaten through as quickly, but it's still turning green on my cloth, which tells me that the acid is getting through to the base metal underneath. Here I have a pocket watch case, and it's not marked anywhere, but I know it's gold filled, but I'm just going to show you a way to test it. Scrape a little bit of the gold off down into the base metal, like I did right there. Apply the 14K test acid to that spot, and you'll see what we get is an immediate reaction as the base metal starts to react with the acid right there. It starts bubbling and stinking. You can smell a putrid odor. But after you wipe it away, if you look on here, you'll notice that we have a thick area of gold, and we can clearly discern between the base metal and the thick coating of gold on there. Let me put this back on here, a little bit more on here. So it reacts with that brass underneath there. I'm just going to leave it set just for a few seconds here. And then we're going to wipe it off. See, karat gold would not produce that green color, nor would it start reacting with the acid. There, I think you can see a little bit better the outline of the thick gold that's over the brass there. Here's a close-up of the experiment where we filed into the metal there, added the 14K test acid. You can clearly see there's a different colored metal down in the middle there that's brass, and it's outlined with a ring of thick karat gold that's bonded to the brass. So this is another way you can just file into it and see the different metals, the contrast of the different metals at the point you filed into it. Here's a gold-filled pocket watch. The spring is broken in there. And if you look around the outer edge of the cover back here, there's usually a spot where you can fit a screwdriver in here and pry it off. But this watch doesn't have that. So what that means is it's got a screw off back. And we can just screw the back off. If you can't find that little slot to pry it off with a screwdriver. And there's our watch movement. Here's the back cover. And in there it says warranted 20 years. And the warranty year length determines the thickness of the gold over the brass. This is 20 years. A 25-year warranted casing would have a thicker coating of the carat scrap over the brass. I've seen 30-year warranted pocket watches from time to time, and those have the thickest coating of carat gold over the brass. So we'll throw this in our clean scrap. That's nice and clean, ready to go. Now we're going to look at taking the movement out. Before we do that, let's take the front cover off. If the back one spins off, chances are high that the top cover is going to spin off as well. Okay, there we go. Pull the front cover off. The movement comes out through the front, not through the back. We've got this piece now. This outer rim will be gold filled, valuable gold filled material. I'll take the glass off and save it and put this in our gold filled scrap bin. We want to try to save the movement, so there's two screws over here that we turn and line up. The other one's already been adjusted to so that the movement just slips out like it just did. So we'll save this movement. It can be repaired and placed in another case. Not quite sure how to get the crown off here, so I'm just going to take a pair of pliers and twist it off. I'm after the case. I'm not worried about saving the case for future use because we're going to be dissolving this in acid. Some of them have a screw in the movement. You got to loosen that screw and move it out of the way, and then the stem will pull right out. In this particular case, the stem is threaded on. The crown is threaded onto the stem, and you got to grab this piece down here inside the watch, and then screw this off, and then pull the stem out. But I do have a piece down here by wrenching on it with them pliers right there. There's a piece of steel down in here that needs to come out. I'm not going to be able to get it out of there now because I've ruined the threads to pull that out. If I'd realized pulling the stem off by unscrewing it and got it out that way, then I'd have been able to get this steel insert out of here. But I'm just going to throw it in with the batch of carat scrap and let it go like it is, and then we'll fish this thing out of here with a magnet. This little piece that's left right here, this is the crown. It's used to wind the watch, and it's going to have some gold filled material connected to it, and we can just kind of pry it back with some cutters here and take the insert out. Hopefully. Yeah, that's the piece of that's just brass there, but this material right here will be valuable. It's got gold, carat gold over brass, so we'll save this. I've got our material all cleaned up and ready to go. So what we'll do now is we'll get a weight on this stuff and see exactly how much we have in here in grams so that we can calculate a yield. Let me do this first. Let me get the watch band caps in small pieces and put that in there first. That's 79.6. Now we'll get the measurement on these larger pieces. Let's see if you can kind of watch what I'm doing here. Alrighty, what do we got down there? We've got 766.5 grams. Here's our gold-filled scrap. And what we want to do now is burn this. Even though we've cleaned it, we still want to burn it. I'm going to add some distilled water to this big beaker here. It's a 4-liter beaker. We're going to add about 1 liter of distilled water. Now we'll add some of the gold-filled scrap to this melt dish. And we'll burn it. We still want to burn it here because there may still be some junk clinging to this. And we want to get that all burnt off of here before we start dissolving this material in acid. All right, I think we got it. So now we'll take our material here. I'm just going to dump this right into the container of distilled water here. And what we'll do is we'll go through, get the rest of this material, and do that with all of this stuff that's in this dish. Just burn off the junk. All right, we've got all our material burnt. I will set this up on the heat. And get prepared to start dissolving out the base metals from this material. Takes about 3 milliliters of nitric acid for every gram of gold filled. So we'll get a rough idea. That's about 2,300 milliliters of nitric acid that we'll need to dissolve all the base metals out of there completely. I'll be using my nitric acid delivery apparatus here. It's just a separatory funnel set up on a little harness that I've constructed. I'll be adding nitric acid. The bottle here says that it's 68 to 70% concentration. So we're just going to go ahead and fill up our funnel here now with some of this nitric acid carefully. Now we'll carefully insert the nitric delivery apparatus to our fume hood. Let me reach up here and get the cap off of our nitric delivery apparatus. And then what we'll do now is start a low flow of nitric acid down into the gold-filled material. I want to just drip this in initially because it's going to react fairly vigorously. What I'll do is add a little bit of nitric to get the reaction started here. Let me measure out about 100 milliliters or so of the nitric acid. And we'll just pour this right on in now. And this will get the reaction kicked off. Get the camera angles right here. This will kick off the reaction and get things started for us. What this will do is the nitric acid will find a way to get underneath the coating of karat gold in there. And once the nitric acid comes in contact with the base metal, which is going to be brass, the nitric acid will dissolve the brass out, but it will not dissolve the karat gold coating that's over the brass. It will leave that intact, and it'll form little shells of what these pieces used to be, and leave those intact, and then we'll recover those shells or foils and then refine the gold foils. Our first funnel full of nitric acid has made its way down into the reaction beaker now. That's 500 milliliters. First dose. I'm going to put a little mark right here and keep track of how many 500 milliliter doses we add to our beaker. I've recharged the separatory funnel with another ½ liter of nitric acid. We got this on the heat now. We've got our first dose of nitric acid in here. Now we're going to establish a flow here. Just a little bit of a drip, and slowly feed the nitric acid in here now. All the nitric has dripped down into our reaction beaker here. So we'll number this number 2, the second charge of ½ liter of nitric acid. Complete. Now I'll take down the nitric delivery apparatus here. Carefully remove it from the fume hood. Going to measure out another ½ liter of nitric acid. Make sure my valve is off down here. Now what we'll do is pour the ½ liter nitric into our separatory funnel here. Now we'll carefully reinsert our nitric delivery apparatus back up into the fume hood. Let me reach up here and get the lid off. Now we'll start another drip down into our reaction beaker. This was our third half-liter dose of nitric. Didn't take long, about maybe 30 minutes. And that's because we could add it a little faster, because most of the base metals now have been put into solution, and all we have in there is gold foils. You can see there's a one of them bangle bracelets is floating in the solution. And what that is that's just a gold foil in the shape of the bangle with all of the base metals removed from it. Now that we've got about 1,500 milliliters of nitric in there, I'm going to go down in here, see if I can move the camera forward a little bit. We're going to get inside here with a glass rod and see what we got. There's the bangle bracelet. It's just a gold foil in the shape of what it used to be. It's very light. All the base metals have been dissolved out of it now. Let's see what we got down on the bottom down here. Oh yeah. There's our gold foils. We've still got base metals in there. I can tell it's still heavy, and we need to do some more nitric acid boils to get the rest of this out of here. The longer we spend boiling this material in nitric acid, the easier our refining will be later on. So what we'll do now is just let this boil vigorously to consume the rest of the acid that's in there with it, and then we'll proceed on and go to the next step. The time is now 7 p.m. We started this process at about 10 a.m. I'm going to pull this down off the heat now. And what we'll do is I'm going to put a little bit of distilled water in here, because this solution will tend to get kind of thick. So I'm going to dilute it down with some distilled water. It's about a liter of distilled water. And you can see our gold foils down here are looking fairly spectacular. Those are just hollow shells of what they used to be. Nearly all of the base metal has been removed now with the nitric acid boils. The solution and the gold foils have been allowed to settle and cool overnight. So now what we're going to do is I've got a big filter funnel set up here, extra large Buchner funnel, and what we'll do is we're going to filter our solution now and get that liquid off of the foils. All right, this giant funnel has come in handy. One of my viewers sent this in to me, and it's large enough where I can pull off all the pour off all the liquid in here. And now let's take a look down inside of our beaker here at these foils. Here's a look at the hollow shells, the gold foils from the gold filled pieces. Most of the brass has been dissolved out of these now, but not all of it. And so what we'll need to do, look at that, man, just little gold foils of what they used to be, hollow shells. This part never ceases to amaze me, looking at these pieces that are used to be items of jewelry, but now they're just the shells of gold. See, the nitric acid will dissolve the base metals, but it will not dissolve the karat gold that's fastened to the base metals. So now what we'll do is add some distilled water to the gold foils, maybe about half a liter or so, a little more than that. Now I'm going to put some more nitric acid in here. We can just dump it right on in now, because most of the base metals have been dissolved, so we don't need to worry about this boiling over on us. Let's cover this up. And we're going to put this up on the heat now and continue removing the base metals from our gold foils. Here's our filter. You can see there's a little bit of gold in there, plus there's some gold mud. That purple mud is gold. So now what we're going to do, here's our solution that we filtered out. Let's get the paper out of here now. Let's see if we can get up on here. I'm going to take this paper out. I'm going to put it in a melt dish. It's going to contain metal in here. So we're just going to put it in this melt dish and save it for the incineration. I've got a beaker here. Here's our filtrate that we just pulled through that filter. It's going to contain a little bit of silver. So what I'll do, put a little piece of copper down in here. I'm going to add this liquid to the beaker with the copper in it. Cement the silver out of this solution. Won't be much, but it'll be a little bit. Let's see if we can get in here with a glass rod. There's our copper. You can see the silver is cementing out on it. Like I said, it won't be much, but we'll recover the silver out of there by cementing it on this piece of copper in our solution. Now what we'll do is push this back out of the way and let it react. And I'm going to pull down the solution we have boiling up here, get it off the heat. If you look down in there, I still see some bubbling, which tells me that we're still reacting metals in there. I don't know, it might be those steel pieces that some of the parts here, the gold-filled scrap, had in it. Let me Let me reach down in here with my glass rod and see how this is looking in here. Oh yeah, look at that. Beautiful. Nice, clean gold foils. Very nice. Nice and light. Yeah, that's exactly what we want to see right there. Perfect. I was nosing around in here, and I thought I seen right there a piece of steel wire. And we don't want this in our material. It's a piece of steel wire. Another thing I want to do is, I've got a magnet here in a little baggie. I'll run the magnet underneath the jug here and see if we pull anything magnetic out of here. So far I don't see a bump. Oh, there's a little bit right there. Those look like some of the watch band caps. Not bad. But I don't see any big chunks of steel in here. But the fact that we're still pulling things with a magnet means that we probably need to continue with some more nitric acid boils. I'm going to let this cool down. And what we'll probably do then is filter our solution out of here and add it to the jar to cement out the precious metals. We've had about 2 liters of nitric acid now poured onto our gold-filled scrap. Here it is. It's been allowed to cool so that I can touch it. Now what we'll do is we'll filter off this liquid. Look at all that purple mud coming down out of the beaker. Try to rinse some of this off now with a little distilled water. That purple mud is going to be gold. Alright, here's our recovered gold foils down in our beaker. These look really good. All the brass and base metals and silver have been removed from these gold foils, and now this is carat gold down in here. Now what we're going to do now, though, I think, now let me run I got a magnet here in a plastic bag. If you run it down around the bottom down here, I don't see a whole bunch of movement. A little bit maybe of movement where there's some still some magnetic material down here, but pretty much we've got everything out of there. So now what we're going to do is we're going to set this back up on in a dish. I'm going to add some distilled water to this now. Distilled water. I'm going to cover this with a little distilled water. Not much. I'm going to add a little bit of nitric acid. Not much, just enough to do a final nitric acid boil here. And we'll put this up on the heat now in the back. And put some heat on this and bring this to a boil. Get any final bits of base metal that may still remain dissolved out of there. This is going to take a while to pull through this filter. It's coming out in just drips. Once we get it pulled out of the pulled through that filter, we'll transfer the liquid up here to the cementation jar where we're cementing out our silver on copper. Okay, and then over here, we're going to wait for this final nitric acid boil to pull the rest of the base metals out of our gold foils. I've been pulling the liquid through a filter now for about 2 hours. Still got a ways to go. And I think what we'll do now, this has been up here boiling for the same length of time. I think we've got everything dissolved that we're going to get dissolved out of here. So I'm going to pull this down off the heat now. I'm going to add a little bit of distilled water to dilute it down a little bit. Probably not necessary this late in the process, but here we go. We're going to just add a little bit of distilled water to dilute it just a little bit. See what these foils are looking like. That looks really, really good. I think our recovery is complete now. If you look, my vacuum gauge is maximum vacuum, and we're pulling the solution through this filter just drips at a time. Got a long ways to go. So what I think we're going to do is I've got some silver cell electrolyte here. I'm going to put a piece of copper in here and cement the silver out of this silver cell electrolyte onto this piece of copper. This is a fascinating reaction to watch. The silver will start coming out on the copper immediately. Here we go. You can see that copper coming out of solution, or the silver coming out of solution onto the copper. That was about a 1.5 hour time lapse. That's always a fascinating reaction to watch because it happens quickly right before your eyes. And so we finally got all the liquid pulled out of this filter. We've got some solids down in here. I need to get that filter out so we can move to the next step. Let's get this filter out of here. See how this is going to go for us. Oh, good. Thank you. Thank you. Thank you. All right. I'll wipe that out with a piece of filter paper and add it in here for the incineration. This reaction, I believe, is complete, so we'll move this out of the way. And now we'll bring up our other reaction beaker going on here. And the filtered solution that we just filtered. I'm going to pour this now in this beaker. It'll have a little silver in it. So we're going to cement that silver out of here onto the piece of copper that's in this beaker. Let me give this a quick stir. See the silver's coming out of solution on that piece of copper in here. Not a whole lot, but maybe an ounce and a half, something like that. We'll set this back out of the way now. Here you can see the funnel's got some gold mud in it. I'm just trying to wipe it out with a filter paper. And I probably should have used one of my specially folded filters for this so that I didn't have this mud getting into this funnel like this. Now we're going to filter the gold foils out of this final nitric boil. I did use a specially prepared filter that goes up the sides of the funnel for this filtering, so we can capture 100% of the solids in there. Now we'll go ahead and filter these solids out of this liquid. I'm going to save the liquid. It's going to have a bunch of nitric acid in it. We can dissolve some more material with that nitric acid. Here's our nice gold foils. I'm going to get these down into the filter now. Our gold foils are complete. They're up here in this funnel. I'm going to take a look at those in a second. And what we'll do is here's our gold foils. Set those back here out of the way for a second. This solution will have a little bit of silver, not much, but it will have much nitric acid in it. I'm going to pour it into my silver jar down here and use the available free nitric that's in this solution to dissolve some of the silver that's in this silver jar. See fumes already starting to form. Our recovery process is now complete. Remember that recovery and refining are two separate and totally different operations. We've recovered the gold foils and a little bit of gold mud in this filter. And this will conclude part 1 of the series. In part 2, we'll refine this material into high purity gold. Alright, this will complete part 1, the recovery of the gold filled material. I'd like to thank everyone for watching.